Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to calculate the standard free energy of a reaction for a reaction that you can get through a stepwise process. So what I mean by that is if you know how to use other reactions that you know the standard free energy change of, and you can add those or manipulate them together to get the reaction that you want, then you can manipulate and add together the standard free energy changes of those reactions to get the standard free energy change of the reaction that you are interested in or whatever your target reaction is. So I did an example before. In this video, I'll do a second example. So here they're giving us a reaction of N2O gas plus NO2 gas is going to give us 3NO gas. So here's our target equation that we want to find the standard free energy change of. And here are the reactions that we are given with their known standard free energy changes. So we need to manipulate these and add them together so that we can get the resulting standard free energy change from here, and that'll give us the standard free energy change of our target reaction. So let's get into this. So here I have this reaction. Here's my target. So I need N2O and NO2 gas on the reactant side. So I'm looking here to see what I have. So N2O, here I have N2O in the reactant side, but you'll notice that I have two here, but only one there. So what I need to do is divide everything by 2 here to get only one of the N2Os. So I do that, divide 2 by 2, and I get 1. So I'll leave that as a 1. And then I divide this by 2, so that becomes a 1. And now here, 1 is already there. I get 1/2. So this is going to be 1/2 O2 gas. Now, again, if I divide the equation by 2, then I must divide my my delta G, my standard free energy change with reaction, by 2 as well. So let me give myself some room here. And so basically, I'm going to take this and divide it by, or multiply by 1/2, right? Same thing. So I'm going to multiply that by 1/2 or divide by 2. And that's going to be the new delta G, the standard free energy of the reaction. Okay, so I've got my N2O, I got my 1 N2O here, I got my 1 N2O here. Great. Here I need NO2 as a reactant. So NO2, I don't see NO2 here as a reactant, but I do have NO2 here as a reactant. So I need to flip this equation. So I'm going to rewrite it down here. So I have 2 NO2 gas, and that's going to give rise to, oops, I should fix that a little bit better. My arrow looks ugly. There you go. Not much better, but I think a little bit better. All right, so I have this as my reactant now. I need, I'm going to write these as my product. So I have 2NO gas plus oxygen, O2 gas. And since I flipped this, right, equation, I need to now change the sign of my standard free energy change of the reaction. So now the delta G for this new reaction is standard free energy change of the reaction is equal to a positive 71.2 kilojoules. So I changed the sign from negative to positive. So I'm going to cross this out so I don't get confused that we don't need that a new one anymore. Okay, so now I have this one. Now again, we now have the NO2 as a reactant, which is, which is here. But here, notice I only have 1 here, but I have 2 here. So again, I'm going to have to divide the equation by 2 so I can get 1. So 2 divided by 2 is 1. 2 divided by 2 is 1. And then I have my oxygen here. I have 1, so I'm going to divide that by 2, and I'm going to get 1/2. So let me give myself some room. So now I have 1/2 O2 gas. And once again, if I divide my equation by 2, I have to divide the standard free energy change by 2 as well. So again, give myself some room. So I'm going to now multiply this by 1/2. And so again, that's going to be equal to the new delta G of that reaction. Okay, so I have my NO2, 1 NO2. I have, where's my other one? I have 1 N2O, 1 N2O, and I need 3 NOs as products. So here I have 2 NO gas. I have 1 NO gas here. No more NO gases anywhere else. So I have the equation. Now, the other thing I need to double check is to make sure the other things I don't have in my target equation cancel out. So I don't have oxygen, right? So, oops. Sorry about that. So I have 1 oxygen here, and I have 1/2 of oxygen. I have 1/2 of oxygen. So the 2 halves make 1. So that cancels out. So the oxygens here cancel out. So that cancels out. That cancels out. And what about nitrogen? I don't have nitrogen, N2. So I have 1 N2 here, and I have 1 N2 here. So that's going to cancel out. And everything else I have. So I can circle the ones I have. So I have N2O here, 1 there. I have NO2 here, I have 1 there. And I have 2 NO here, and I have 1 there. So I have 2 plus 1 gives me 3. So then now I can add these together, and I get my target equation. So I get N2O gas, N2O gas plus NO2 gas gives me 3 NO gas. And so in order to get the delta G, all I do is add these together. And when I do, I get my answer. Let me double check. And I get delta G for this reaction is equal to 107.1 kilojoules. So that is the resulting free energy change of this reaction. Again, it's positive, so you know that this is not a spontaneous reaction. So I hope this was helpful. If you enjoyed this video, if this helped you in any way, then please do me a solid and subscribe to my channel, hit that notification bell. Also, make sure that you share my videos with others. Make sure you like the videos, hit that like button, and finally, put a comment down below so that way you can let me know how you feel, what you think of the videos. Do you have any suggestions? Do you have any questions? I would love to hear from you. Thanks for joining me, and have a great day.